Hello everyone, my name is Shambhavi. Hope you all are doing well. So welcome to this another part for the Python interview series. Now basically what we are going to see as the another 5 questions for the Python interview series. In that basically we are just going to see the most asked Python interview questions, right? Now to begin up with the very first question I have that what advantages do numpy arrays offer over Python list? Now basically when we just talk about pythons, in that cases numpys are also one of the libraries which are actually mostly used, right? We just talk about numpys are libraries a very lot. Now in that case basically we are going to see that what are the advantages of numpy over list, right? Over python list, what is the what is the basically way, what is the basically reason, what is the advantage that why we just always prefer using the numpy arrays over list, right? We are just going to see this answer today. Now please listen to me very carefully because this is a very asked question which is generally asked a lot in the interviews, because arrays and list, they both are actually a little bit of same to each other, right? They both are actually a little bit of equal to each other. There are some minor differences which makes arrays and lists different from each other, right? Let's begin up with the things for here and let's start. So the advantages to numpy arrays offer over python list. So let's start up here. So I would be just writing out the answer and let's write out and understand. So I'd be adding here that Python's lists are efficient. Python lists are efficient. General purpose containers are efficient. General purpose containers. Okay, these are the efficient general purpose containers, right? So this is about the list. Now, basically, what they actually do. So basically after this they support the efficient insertion, deletion, appending, and all those things are actually supported by the python list, right? We can just append on that, we can just remove any element, we can just perform the insertion, we can perform the deletion. All of these basically are performed on the python list, right? So these are the things which you can just perform on the list as well, right? And the python lists are actually comprehensions, right? They make them easy to basically construct and to manipulate, right? These are the differences. This is the very first thing about the python list, okay? So my question is that what advantages do numpy arrays offer over python list? Okay, so first of all, this is my about my python list. Now other than this, if I just discuss about my numpy arrays, okay, if I just discuss about my numpy arrays, so basically there is certain conditions, there is certain limitations that we cannot perform the vector functions on the list, we cannot do, right? But we can do that on the numpy arrays, okay? Vector operations cannot be performed on that, right? Let's say we just cannot do the element wise multiplication, we cannot do the element wise addition. All of these things cannot be performed on the list, but they can be performed on the numpy arrays, right? And basically the fact is that they actually contain the different types of list contains the different types of data types as well, right? But in numpy arrays do not contain different types of elements, they different types of data types, they just basically contain only and only the numbers, right? So I hope that you have got an idea regarding the difference, right? So I've just not written that because if I just gonna write, that will take a lot of time and even that would be a little boring for you as well. So I would just let you know about the advantages of that numpy arrays offer over python list. Now I'll be letting you know the very important thing. So in that case, I'll be writing here that numpy is not just okay, let me write that thing in a clear handwriting so that you are actually able to understand that afterwards as well. So numpy is not just more efficient, and I would just like talking about the efficiency, right? So I would just write that numpy is not just more efficient, efficient, but it is also convenient to use, but also convenient. Let me write that, convenient, right? It is not only efficient but it is also convenient. Basically we just get a lot of vector, a lot of matrix of operations which we can just perform on the numpy arrays, right? And that is absolutely for free, right? We can just perform any vector, any matrix operations for free, and we can just like deal with the very large numbers as well, basically, which take a lot of time. By using the pen and paper, basically it takes a lot of time to find out that things, find out that values and all those things. But with the help of that numpy, it is the things are very easy. Just write out the thing, just use that function, and simply you'll be getting your exact answer, right? So this is basically means that numpy is not just more efficient but also convenient as well, right? So, and even that numpy is faster because we just get a lot of built-in functions in the numpy arrays. Okay, numpy arrays is faster, and you basically get a lot of built-in functions in the numpy arrays, right? So basically these are some like advantages of numpy arrays over Python list, right? I hope that you have listened to me very carefully, because I have not written these things here because there's no meaning of writing that thing. I'm just telling you, I'm just briefing you, and I'm just like detailing you about the things, right? So Python lists are efficient general purpose containers, right? NumPy is not just more efficient but also convenient to use. Basically, lists do not support the vectors and the matrices, but numpy array does. Basically numpy arrays is faster because we just get many lot of built-in functions in the numpy arrays. Numpy arrays is more efficient but also convenient because it offers us many functions for the matrix, for the vectors, that it actually help us to save our time, that actually help us to save our unnecessary work, right? So these are some advantages that NumPy arrays offer over Python list, right? I hope that you have got a clear idea regarding this question, that what are the advantages NumPy arrays offer over Python list, right? Let's come on to the next question for now. So my second question for today is that basically whenever Python exits, okay, whenever Python exits, why is not all the memory deallocated? Okay, wait, now this is a very interesting and a very conceptual question as well. That whenever this Python exits, right, whenever we just close out the Python, then basically why all the memory which we have that does not get deallocated, right? This is the question that is actually asked. So for this, basically, I'll be giving out you the proper write-up as well for this question. Okay, so I would just start writing that whenever, I would just write down the question with this way, that whenever the Python exits, okay, whenever Python exits, especially, whenever Python exits, especially, those Python modules which are having, like especially those Python modules which are which are which are having circular references, which are having circular references to other objects too, which are basically having circular references to other objects, and basically they are referenced, they are referenced, referenced. Let me just get out some space here so that I can just write out. Okay, so they are referenced from the global namespace, the global from the global namespace, are are not always deallocated, right? So basically, whenever Python exits, especially those Python modules which are having circular references to other objects, they are referenced from the global namespace, and that is the reason that they do not get deallocated, right? Now, basically, the answer for the question is that whenever the Python exits, right, especially when we just use any Python modules which are having several references to the other objects as well, so they are referenced from the global namespace, okay, and that is why, because the memory does not get deallocated always, right? This is the very first reason for the answer of this question. Uh, second, second, right now, second thing comes that basically on exit, because of having because of because of having, okay, just let me write that thing like this here. Okay, on exit, because of having own efficient clean up mechanism, right? So basically on exit, because of having own efficient cleanup mechanism, so Python would try to deallocate. Let me just, okay, I'm sorry, let me just come down first of all. Python would try to, the Python would try to deallocate slash destroy every other object. So this is the reason that why does this actually try to deallocate the memory, and basically, so on exit, because of having own efficient cleanup mechanism, Python would try to deallocate slash destroy every other object. But so my question was that why is not all the memory deallocated? So this is the reason that first of all why it actually tried to deallocate the memory, because of having its own efficient cleanup mechanism. Python would try to deallocate slash destroy every other object whatever it will be having, right? So this is the answer. Other than that, basically there comes one more very important reason, and that is, okay, let me just give some space and then write because it's like a mess up. Okay, I would just write it is impossible. It is impossible. It is impossible to deallocate. It is impossible to deallocate those portions. It is impossible to deallocate those portions memory that are memory that are reserved by the C library. Okay, this is the another very important reason which you can just list on, that it is basically impossible to deallocate those portions of the memory that are reserved by the C library, right? So this is the answer for all of these these three are the answers for this question which is coming here, that whenever Python exits, why is not all the memory deallocated? So these are the three reasons regarding these these are the three reasons regarding this question. Right, now let's move on to the other question here. And now here comes about my third question, that basically what is the difference between the range and an X range, right? So this is the another question which is coming, that let me know the difference between the range and the X range. Okay, so let's write come here. Fine. So basically for most of the parts, this range and X range actually work, and basically they just generate the static list and some they basically are exactly the same. Okay, for most of the cases. But they both, and basically what's the use of this? So they both actually provide and generate a list of integers for you to use. Okay, so basically first of all the very most part is that exchange and range are the exact same in the terms of functionality. If we just talk about the functionality, okay, I would just write that they are same in functionality. So what do they actually do? So they would provide a way to generate the integers for you. Okay, so basically they both provide they both provide a way to generate a list of integers, not only integers, a list of integers. So the very first thing is that basically what is the functionality that they actually perform? So these are actually same in the functionality. They both provide a way to generate a list of integers for us, right? The only difference is that the range function returns a Python list object, and the X range returns an X range object. Only this is the basic difference which comes between the range and the X range. Let me write out that thing. So range, I'll be writing that range returns a Python range returns a Python list objects. Okay, this is the first thing that comes. The range returns range returns a Python list object. Okay, and basically comma, I would just add comma x range x range returns an x range object. This is the very basic difference which is basically between both of them. So basically the difference comes is that, let me just write up here. So the difference is that range actually returns a Python list object, and X range actually returns an X range object. Okay, this is the difference which comes here, right? Let's move on to the next question for now. Okay, just 1 minute. I'm sorry. Let me just write out like this. Right. Now my next question is that what is the difference between Python arrays and lists? So that question we had already seen right now, right? That what is the difference between the Python list and arrays? Let me just repeat that thing. I will just not write that here, okay? So basically the difference comes is that Python arrays actually they only store one single data type, that is the integers, okay? And lists basically what they do, they basically store different data types as well. Let's say they can store integers, they can store float values, they can store characters, and all of these things can be stored one single variable only, right? But in Python arrays this is not the case. In Python arrays you can only and only give the integer values, right? This is the very basic difference that comes between the Python arrays and the list, right? So Python arrays hold only single data types, but list actually holds different data types onto it, right? Let's see an example, okay? Let's see an example here. So for that array I would need to write import array as ARR. This thing we had already seen previously in the some part for this course as well. We had already seen this thing, right? So import array as ARR. Let's say I just took out let's say a variable, that is my variable is, let's say own underscore. Okay, let me write that in a clear handwriting. That is ARR. And let me just write that own underscore array. Like this, let me just write it out here, okay? So own underscore array. So in that basically I'll be storing ARR dot, and that is capital, okay, that is A would not be capital, A would remain as so small, okay? This ARR is my, what is it actually? So this ARR is the short form which I have given to this array, and this array is actually my function. I will just write out like this, that let's say my variables are 1, 2, 3, 4. Let's say these are the numbers which I have just stored, right? And I would just define my list as well, so I will just write own list, okay? So for defining the list, and this is not put, this equal to is put, okay? Own list is equal to, so large brackets, and here I can just write A, then 1, and then 10.2, then I can just write B. So you can just write any number of data types, whichever you just want here, okay? And for printing, both the procedure is absolutely same. Inside the print statement, you will be writing own underscore array, okay? And inside for the list, we'll be writing print own underscore list, right? That is absolutely same. Only difference comes about the storing of the data types. That basically in arrays you can store only single data types, but in list you can just store any n number of data types whichever you just want, right? So I hope that you have got a clear and a fair idea that what is the basically that difference between the arrays and the Python list, right? Now let's move to the another question, and let's see that what is PEP8, okay? PEP8. So let me write that PEP actually stands for, PEP actually stands for Python. I would just write that another thing on the downside, okay? Because the spelling is little long, okay? So Python enhancement proposal, and here it is proposal, right? So PEP stands for this thing. PEP stands for Python enhancement proposal. And what does it actually means? So it is basically, it is a set of rules that it is a set of rules that specify, okay? It is a set of rules that specify, let me come down, okay? It is a set of rules that specify how to format Python code, for maximum readability, This is actually what this PEP stands for. So that is readability, okay? Readability right here. So it is basically this PEP. It is first of all, the full form is that Python enhancement proposal, right? And other than that, what it actually does, so it is a set of rules that specify how to format, okay? How to format, that is not formal, how to basically format Python code for maximum readability. So basically it is a kind of enhancement proposal in which basically it is a set of rules that specify that how you can format Python code for the maximum readability. Right, so these were the 5 questions that we have discussed today. Let me quickly give you a recap of all those here. So the first question was that what advantages do numpy arrays offer over Python lists? This was the very first question that we had seen. After that, we had seen that when your Python exits, why is not all the memory deallocated? Listen to me very carefully that this is a very important question and a bit tricky question as well. This needs a little bit of explanation as well. Okay, so just like make sure to have a proper revision of this question. Okay. After this, we had seen that basically what is the difference between range and an X range, right? We had seen the difference between both of them. Other than that, we had seen the difference between the Python arrays and the list, and our last question was that what is PEP8, right? So I hope that you are very much clear with all of these 5 questions which we have discussed today. You have got a clear idea that how to answer if something comes from these questions, how to answer out the question, and we have even discussed some like revision and some basic concepts as well, right? So we'll be continuing with more questions in the next video. So this is all for this video. Till then, thank you and take care.